The next section of our Udemy course um, will be the first in series of sections intended to introduce the use of Android services to perform application tasks in the background. It's impossible, however, to understand the steps involved in implementing services without first gaining a basic understanding of the concepts of threading in Android applications. Threads and async tasks class are therefore topic of this section. Um, Actually, in this section, you will learn coroutines as well. So, an overview of threads. So, threads are the cornerstone of any multitasking operating system and can be thought of as mini processes running within a main process, the purpose of which is to enable at least the appearance of parallel execution paths within applications. We have the application's main thread here, main thread, as you can see here in this diagram. So when an Android application is first started, the runtime system creates a single thread in which all application components will run by default. So this thread is generally referred as main thread. So let me change this default. No. Okay. So this is generally referred to as the main thread. So the primary role of the main thread is to handle the user interface in terms of event handling and interaction with views in the user interface. And additional components that are started within the application will, by default, also run on the main thread. So any component with an application that performs a time-consuming task using the main thread will cause the entire application to appear to lock up until the task is completed. So this will typically result in the operating system displaying an application is not responding warning to the user. So clearly this is far from the desired behavior for any application. So this can be avoided simply by launching the tasks to performed in a separate thread, allowing the main thread to continue unhindered with other tasks. So in Android we have thread handlers as well. So clearly one of the key rules of Android development is to never perform time-consuming tasks on the main thread of an application. So the second equal important rule that is the code within a separate thread must never, under any circumstances, directly update any aspect of the user interface. So any changes to the user interface must be always performed from the main thread. So the reason for this is that the Android user interface toolkit is not a thread safe. So attempts to work with non-thread safe coded from within multiple threads will typically result in intermittent problems and unpredictable application behavior. If a time-consuming task needs to run in a background thread and also update the user interface, the best approach is to implement an asynchronous task by subclassing async tasks here. So now we will create an basic async task example. So the remainder of this lecture will walk through some examples intended to provide an introduction to thread and the use of the async task class. The first step will be to highlight the importance of performing time-consuming tasks in a separate thread from the main thread. So now let's get started by creating our project. So select the create new project in Android Start Studio welcome screen, and with this dialog choose empty activity template before clicking on the next button. So click on that, or you can double click on that, of course. So now enter the async demo tech pins to name field, and here you can assign a package name as well, and language to Kotlin, and Android API to 26, Android 8.0 area, and click on finish. So the Gradle will build our project file now. So it may take 10 to 25 seconds. Actually, it depends on your computer's performance, but it's doing now. Here Gradle is building our file, project, not file. Here Gradle is building our file, project. So after Gradle configured project, we will open our first activity main XML file and do something in it. So we are waiting to complete Gradle build here. Okay, so our Gradle build is completed. So now main project into the layout editor here, layout here, and double click on it and select the default text view component and change the ID for the view to here, for example text view, just an I here, or let's make it a bit special here. Let's change this ID to my text view here, and let's change text size to 24 SP for better here. And now we need to add a button view user interface position directly beneath the existing text view object here. So here let's constrain it as well. Okay, and once the button added, click on Infer Constraints here and make constraints for this. And now change the text to press this button here, and here let's assign onClick property to it. OnClick property to click me button here. Click me button. Okay, and actually not click, press button. So next here we done with it, and let's open main activity Kotlin file. Okay, so let's open main activity Kotlin file here, and we will add two, actually one import one view here, we import Android view here, and let's add our class that we declared in onClick property of this button. What was it? OnClick here, press button here. So function press button, and this will take an view from view class, and this is our function. So when we click this button, we will create a variable and initialize it to 0. So while is our variable is less than or equal to 20 here, then thread dot sleep, for example 1 millisecond here, and then e++. So after, if any exception occurs, actually we have to it can throw an exception, so we will try a catch block to it in while block here. Try thread.sleep sleep 1000, and then increment e by 1, and here catch e exception here. So lastly we have to initialize our text view that we give an ID here, my text view here, and so actually late init variable my text view, this will be text view here, text view, and let's import this as well. And here let's initialize our text view my text view equals initialize find view by id or that id that give your text view id here. And lastly, if catch just let's if any exception occurs, write it to our text view here. So text my text view that text here equals assigned to our string. So e dot get message, e dot message here. It's just an old Java thing. So then not in while block, we will write in our function just after completing while block, my text view dot text is equals to button pressed. So now within the code chains complete here, let's run the application on a physical device or an emulator. As I did, I am running our example projects in emulator. Once the application is running, touch the button. So we will wait it now. So I will pause this video here. Continue after our application while compiling. Our application is compiled and we are waiting to install here. So here when we press this button, as you can see here, after 1 second it will crash. As you can see, our application is not responding. So when we click on this button, at which point the application will appear to freeze. So it will, for example, not be responsible to touch the button a second time, and in some situation the operating system will crash here. Async demo here, as you can see here, we can press any screen here, but when we press this button and we execute this function, our application will crash. So clearly anything that's going to take time to complete within the button clicking methods needs to be performed with a separate thread. So now we need to subclass the async tasks here. So now what we will do in order to create a new thread, so as you can see we are failed, so we cannot use thread in main thread, so we will create async task. So in order to create a new thread, the code to be executed in that thread needs to be performed within an async task instance. The first step is to subclass the async task in the main activity content file here. Let's import first let's import async task here. Import import 1 minute, I'm configuring my monitor here. So import android.os async task. So then we will create an inner class in main activity here. So private inner class my task. This will be async task here, and this will take string void and string as well, and this is the method here. This and then we will declare our functions actually. So these are the on pre execute override here. Let's on, so on pre execute, on pre execute, on post execute here doing background, and on cancel it here. So we will import here on pre execute, on doing background, on progress update, and on post execute. So click on OK. For attention to you, I pressed Control plus O button here to override members of class here. So now we will edit this class after here. So the async task class uses 3 different types, which are declared in the class signature line. As you can see, a string, void string, type 1, type 2, type 3. So these three types correspond to the argument types for do in background, on progress update, um, and on post execute. So methods respectively. So if a method does not expect any argument, then void is used. As is the case for the on progress update in this code here, so we can change this to int here, but it's void. Okay, as you can see, we're getting error because these are values void. So the on pre-execute is method is called before the background tasks are initiated here. And can be used to perform initialization steps. So these methods runs on the main thread, so may be used to update the user interface. So this on pre-execute here runs on the main thread. So the code to be performed in the background on a different thread from the main thread resides in the do in background. So this is the background method. So if you want to write some codes here, so you will write in it. So this method does not have any access to main thread, so cannot make user interface change. So this doing background method cannot change any user interface changes. So the on progress update here method, however, is called each time a call is made by publish progress method from within the do and background method, and can be used to update the user interface within the progress information. So the on post execute method is called when the tasks performed within the do in background method complete. So this method is passes the value by returned by the do in background method and runs within the main thread, allowing user interface updates to made. So modify the code to move the timer code from the button click method to the do in background. So here we will actually do here, we will cut this, actually not this, right? So here we will write another code in do in background here, var e0 while e is less than or equals 20, then try thread.sleep 1 millisecond 1 second, and then increment e by 1. So then we have to write catch block here, e exception, and here in exception we will return here e dot localized message, and lastly we will return button pressed here. So next move to the text we've update code, and next move to the text we update code to on post execute method, where it will display the text returned by the do in background. So on post execute, take my text view. Yes, you can see we can reach it. So on post on post execute we will write my text view dot text here is equals result here. As you can see, we're getting this result from here. As you can see, we returned something to it. This is the result. So to provide regular updates via the do in background method, modify the class to add a call to the publish progress method in the timer loop code passing through the current loop counter. So, and to display the current count value in the onProgress method here, so we will use it here, publish progress e. We will pass e to it, and when onProgress update, here on progress update, we do something here. So we will add counter, val counter values the dot get 0. So my text view dot text is equals to counter equals counter here. So by default, asynchronous tasks are performed serial. So in other words, if an application executes more than one task, only the first task begins execution. So the remaining tasks are replaced in a queue, so and execute in sequence as each one finishes. To execute asynchronous tasks in parallel, those tasks must be executed using the async thread pool executor, like that, for example. So we can delete this here, delete this as well. Val task my task dot execute on execute on executor, and we will pass an argument async task that thread pool executor. So the number of tasks that can be executed in parallel using this approach is limited by the core pool size in on the device, which in turn is dictated by the number of CPU cores available. So the number of CPU cores available on device can be identified from within an application using this code here, val CPU cores is a, and then runtime dot get runtime available processor. So this will give this total CPU cores to us. So Android uses an algorithm to calculate the default number of pool threads, but the minimum number of threads is 2, while the maximum default value is equal either 4 or the CPU core count -1, whichever is smallest. So the maximum possible number of threads available to the pool on any device is calculated doubling the CPU core count on and adding 1. So let's test our application here. Actually, we have one error. Where is this error? Here. So required void. Okay, so we can delete this as well, right? So now we have not any errors, so we can build our project. So it's building. And our application is launched. When we press on this button, 1 second waits, and then writes to it. So this lecture has provided an overview of threading. Actually, we haven't executed it, right? So task that execute here. So this lecture has provided an overview of threading within Android applications. When an application is first launched in a process, the runtime system creates a main thread in which all subsequently launched application components run by default. So the primary role of the main thread is to handle the user interface. So any time-consuming tasks performed in that thread will give an appearance that the application has looked up. So it is essential, therefore, that tasks likely take time to complete be started in a separate thread, because the Android user interface toolkit is not thread safe. So changes to the user interface should not be made in any thread other than the main thread. So background tasks may be performed in a separate thread by subclassing the async task class and implementing the class methods to perform the tasks and update the user interface. So now we will actually in next lecture we will learn Android coroutines, which is better than threads to execute codes here. So I'm waiting